Our objective for today, I can identify properties of real numbers. Let's read it together. 1, 2, 3. I can identify properties of real numbers. Now, we already started some of these properties, but today we're going to clarify some of the doubts that we might have on some of them. Okay? So you have the handout in front of you. Write your, you already have the objective down there. So make sure you circle in red, identify, and in green, underline properties of real numbers. Circle, identify in red, and properties of real numbers in green, so that we know what what concept we're still on. Okay? So our concept for today is properties of real numbers. And what are we doing? Identifying. Okay? So real numbers, we already know what they are. I gave you that some time back. Remember that? And I said, set of all numbers that can be represented on the real number line. Any number on the real number line. Whatever is not on the number line, on the real number line, then they're called what? What is this one called again? Imaginary. That is correct. And we said that we cannot have a negative square root or a fourth root or an even root. Okay? So therefore, continue. Steps. I give you guys steps to identify the properties of real numbers. Number one, very important, you need to look for what operation is being presented throughout. It can only have one throughout. Okay? Step two, identify the name of the property. Once you know what operation, then identify what property is being used. And that's when you're going to give it a name. And step three, we're going to use that property. What are we going to use it for? For proofs. You're going to see that in a little bit. And also to simplify expressions. So things to circle on your notes. Step one, identify and underline operation. So like that, you remember, that's the very first thing you're going to do. Identify the operation throughout. Step two, identify, circle identify, and also a circle name, underline property. So we're going to identify and name the property. And step three, we're going to use the property. And since you guys like to argue, today we're going to use it for proofs. And that's going to help you argue. Okay? Not with your parents, probably, because they're, you're going to be like, yeah, well, the commutative property says no. That's going to be for here in class. So, with that said, 3 easy steps. Number one, identify the operation throughout. Step two, identify and name the property. And step three, use the property. Step one, identify the operation throughout. Step two, identify and name the property. Step three, use the property. Step one, identify the operation throughout. Step two, identify and name the property. And step three, use the property. Okay, tell your neighbor the steps and have them tell you yours. Please, the same one. All right, here we go. So let's continue. So we got the steps. So I gave you guys on your notes this table. Everybody there? Okay. First, I'm going to show you with numbers and then with algebraic expressions. So now check this out. I want you to circle in here 2 things that I'm going to be looking at, 2 different operations. It says here addition and multiplication. Circle that so that you know that we're looking at add and multiply for both properties. For this one also, we're going to be adding and we're going to be multiplying what I'm circling on the screen. Okay? So that we understand we're going to be doing the same thing for both, and it works for both. So here we go. First in red, I'm going to do here with numbers the commutative property. So check this out. I'm going to do addition in red. 8 plus 15 plus 2. Okay, you're just paying attention right now. Everybody look up, please. Check this out. The commutative property says that if there's addition throughout. So what was the first step? Identify the operation. Do we have the same operation throughout? Yes. So that's the first thing. Second thing, what property are we looking at? Commutative. So right now I'm going to tell you what it does. If we have addition throughout, then the commutative property tells us that the order doesn't matter. The sum will be the same. So check this out. By looking at this, what would be the easiest numbers to add from these 3? So then I can rewrite it as 8 plus 2, and then at the end plus 15. And the commutative property tells me that the order doesn't matter, the sum will be the same. Let's see. What is 8 plus 2? Plus 15? 25. Now let me go the long way. What is 8 plus 15? 23. Plus 2? 25. Is 25 equals to 25? Yes, so the commutative property does work. Okay, copy that, please. Okay, and whatever works for addition, that's what we did here, works also for multiplication. Focus, please. I'm going to do multiplication in blue so you can see the difference. So pay attention, please. So I'm going to use the same numbers. 8 times 15 times 2. And it says that the order doesn't matter, so I'm going to switch these around. What if I write 2 times 15 times 8? Okay, let's see. This is easier, right? What is 2 times 15? 30. What is 30 times 8? Or 3 times 8? That's 24 and not a 0. Okay? Let's go the long way. 8 times 15. Let's see. What is 8 times 10? 80. 8 times 5? 40. What is 80 plus 40? 120 times 2? 240. Do we get the same product? Yes, so the property does work for multiplication only. Also. Copy that, please. So, let me show you now with algebra. This is what it says. Let me use 3x plus 2y plus 4x. Which of these is easier to combine? Which ones can combine? So I can move these around, so this becomes 3x plus 4x plus 2y. So, let's see, what is 3x plus 4x? 7x, and at the end we just bring down the 2y. Can we combine the 7x and the 2y? No, that's it. Now let me go this way. Let's see if I get the same thing from here by doing what we did with the boxing and all that. Same term, same term. Are these like terms? Yes. What is 4 plus 3? 7x. And what do I bring down? Plus 2y. Do we get the same thing? Yes. Commutative property does work. Let's look at multiplication. And I'll do that in red. For multiplication, let's do 2x plus 3x plus 10x. I'm going to switch these around. What do you want me to write first? Okay, 3x times 10x times 2x. Oh, I put plus right here. My bad. It's times. Sorry. Multiplication. So let's see. What is 2 times 3? 6. Okay. 6x squared. Times 10. What is 6 times 10? 60. What is x squared times x? X cubed. So let's see if it works. What is 3 times 10? 30. What is x times x? X squared. Are we there so far? What is 30 times 2? 60. What is x squared times x? X cubed. Did it work? Yes, the commutative property also works with multiplication and algebra. Okay? All right, let's look at associative property. Here we go. Pens down, eyes up here, please. Check this out. I'm going to use the same numbers so that you can see the transition here. 8 plus 15 plus 2 equals 8 plus 15 plus 2. And the associative property says it doesn't matter how I group them, the sum will be the same. Now, before I move on, think about this question. What do you notice here in the associative property from here in the commutative? Think about it first. What do you notice here from here? Think about it. Talk it over with your neighbor, see what you see. All right, so we see that, do you see that the order did not change from this side to this side? Look, 8, 15, and 2, and then here is 8, 15, and 2. You guys see that it's the same on both? Okay, so one thing that you're going to be able to tell from the commutative to the associative is the associative, the order stays the same. Okay, so make a note for yourself over here on the side. Make a note and write, what's that? On the Q side over here, on this side. Let me make this, yeah, over here on the side, make a note and write, ask if the order changed. Why do you think that question would be important? Did the order change? So you would ask by looking at it, did the order change? Will you be able to tell which property we're talking about just by the order? Yes, look at that. Which one did not change? Associative. So here, what the associative property says is that it doesn't matter how we group things, the sum will end up being the same. So fix up. I'm going to start with parentheses here. What is 8 plus 15? 23. And then in the end, plus 2. Plus 2, 25. Now let me go over here. What is 15 plus 2? 17. And then we add 8. What is 8 plus 17? 25. Did the sum change? No, it's the same. So it doesn't matter how you group them. That's what the associative property says. When there's addition throughout, it doesn't matter how you group them, the sum will be the same. Copy that. And guess what? If the associative property works for addition, it also works for multiplication. Let me use numbers for this one. For multiplication, say numbers 8 times 15 times 2 equals 8 times 15 times 2. What did we notice once again? That the order didn't change. And I'm going to group, which ones do I group here now? I'll group 15 and 2, and over here 8 and 15. Okay? So let's see. What is 15 times 2? 30. And multiply that times 8. What is that? 240. Let's see. What is 8 times 15? Let's see. 8 times 10 is 80. 8 times 5, that's 40. So this is 120. And then we multiply times 2. What is 120 multiply times 2? 240. So is 240 equal to 240? Yes. The associative property also works for multiplication. Okay? And whatever we can do with numbers, we can also do with algebra. So let's do this. I'm going to give you some variables here. Let's do, I'm going to use these same ones. How about 2x plus 3x plus 10x equals 2x plus 3x plus 10x. And I'm going to group them differently. I'm going to group these two first, and then over here I'm going to group the 3x and the 10. So let's use our order of operations, and we're going to start with parentheses. What is 2x plus 3x? 5x, and I bring down the 10x. Bless you. What is 5x plus 10x? 15x. Did it work? Let's see. Find out. Inside of parentheses. 3x plus 10x, that's 13x plus 2x. What is 2x plus 13x? 15x. And yes, it did work. And guess what? If it works for addition, therefore it does work for multiplication. So let's do that. Rewrite it but with multiplication. 2x times 3x times 10x equals 2x times 3x times 10x. Bless you. And let's group these. Which ones do I group? Okay, 3x and 10x. and 2x and 3x. And of course, we need to do whatever's inside of the parentheses first. So let's do these two first. 3 times 10, that's 30. X times x, that's x squared. And I multiply that times 2x. 2 times 30, that's 60. X times x squared, that's x to the third. Because it has to the first power of the x, right? So look at this one. 2 times 3, that's 6. X times x, that's x squared. And I'm going to multiply that times 10x. 6 times 10, that's 60. X squared times x is x cubed. Did it work? Yes, it does work. Everybody understand the commutative and associative property, right? So tell your neighbor what would be the question that you're going to ask if they're asking you to see which property it is. What would be the first question you ask? Thank you. And I heard, does the order change? Yes, that would be an important question to ask as you're trying to identify properties. Okay, let's move on. Underneath that, I gave you guys distributive property. Yes? Okay, copy this down, please. Distributive property. I gave you guys these boxes, so write 3, open parentheses, 4 plus 8, close parentheses, equals 3 times 4 plus 3 times 8. Then right here, they simplified for the second step. What's inside of this parentheses? What is 4 plus 8? 12. What is 3 times 4? 12. 3 times 8? 24. What is 3 times 12? That's 36. What is 12 plus 24? That's 36. And with variables for A, B, and C, they show you here A times B plus C. And here, make sure you draw your arrow so that you know what you're doing here, guys, if you don't see it. Here, we multiply this times this. That's how we get this and this. Same here over here. What is 3 times 4? Well, they write it out right here. Do you see if they wrote it out? And what is 3 times 8? They wrote it out right here. It's 24. Okay? Make sure you draw your arrows, please. All right, so distributive property, we've been using that already, so it's probably the easiest one to remember. The other two, I need some practice. So copy these down, please. Example 1. Example 1. It says, name the property that is illustrated in each equation. So for this problem, just write name the property, and then copy A, B, and C, and then we're going to go over these one by one. Okay, let's see. Let's look at A. Turn to your neighbor, let them know what is the question that you're going to ask right off the bat. Okay, so then the question would be, does the order change? Let me look at it. 7, M, N. Does it look about the same over here? 7, M, N. The order of the numbers and the variables is the same. So if it's the same, now we look to see if it has parentheses. Does it have different parentheses? Do they group them differently? Yes, so therefore this is associative property. What operation are they using throughout? Of multiplication. If you don't write of multiplication, then I'm going to mark it incorrect. I just don't want to see associative or commutative. I want you to understand what operation is happening throughout. Look at number 2. Letter B. Tell your neighbor the question, please. Did it change? No. So then we're assuming it's associative. Let's see. Yeah, because they're grouping these two first and over here the last two. So it's associative property. And what operation are they using? Of addition. Okay? Look at the third one. That one's a tricky one. So here we go. Does the order change? Yes, it did change. So that means we needed to move some stuff around, didn't we? Okay. So if it did move around, then what is it? commutative property of addition. Okay, let's move on to the next one. Look at these. You don't have to copy them. Just look at them. Let's see if your noodle can absorb what they are. Think about it. Okay, let's see. Who saw that this one, the order changed? Who saw that it's addition? So therefore, this is commutative property of addition. Look at this one. Did the order change? No. So all they're doing is grouping differently. So this is associative property of addition. Look at these. Did the order change? Yeah, so this is commutative property of multiplication. Have we got it? Okay. Let's move on. Now check this out. Counterexamples is a way of arguing. And I said, today we're going to learn how to argue using counterexamples, right? Here we go, using properties. So, for example, if I was to give you the statement, no month has fewer than 30 days, what would you say? False. What would be your counterexample? So you would write February has fewer than 30 days, so the statement is false. Okay? Right. So therefore, whenever you argue something, you need to give a counterexample. Let me give you another. If I said, every integer that is divisible by 2 is also divisible by 4. So one thing that we would start checking is numbers to see if they're divisible by 2 and 4. And then you're going to see that, for example, the integer 18 is 18 divisible by 2 evenly. Is it divisible by 4 evenly? No. So that's a counterexample that you would say, no, Mr. Q, you're wrong because I found this number. Everybody with me? Okay. So let's see. Let's look at this example. Find the counterexample to disprove the statement. The commutative property is true for raising to a power. So let's see. Let's see I gave you the exponential expression 2 to the third. What is 2 to the third? First of all, 8. Are we there so far? But it's saying that the commutative property is true. That means that it works also for raising to a power. So that means I need to change the order. So what would be the base now? 3 to the second. What is 3 to the second? Is this true? No, so this is false, and this will be my counter example. Okay? All right. So for homework, I need you guys to just read the next portion, which is finish up the counter examples of examples, and I need you to read where it says closure. Just read into closure, and tomorrow we'll address it. And yes. So homework for tonight. Homework is on page what? 45 to 46, numbers 1 through 35 odd. Do your homework. Have a good one, guys. See you guys tomorrow.